I have a 40-watt light bulb hooked up to that. I'm going to squeeze this and see if I can. I gotta try some of these knobs. I'm watching the meter. Got her in there good? I think so. Where's the tube? That tube wasn't blue like that. The little blue that comes up and on that 12BY7, I think it is. That's legit. Okay, I have to pull this out and put the antenna in.
The time is 11 o'clock a.m. On W0GKP repeater.
Almost missed it. That's what I wanted to plug in for. Now I gotta wait another hour. This is not a very active channel. But I think this is where our storm watch is. In the summertime I discovered that old ham radio guy from the 1990s gave me the frequency. It's still a good frequency today. Whoops. So here's what we're working on here. So I have it running. Obviously, I got the filaments going. B plus, 300, 425 volts or whatever. Got everything going inside of this SOB. Hope I don't upset anybody. I don't think I will. I'm just not going to make a habit out of this. I'm hooking the wire back in here. Unscrew that, screw that back in. It lit up on for me earlier. I don't know why it won't light up now. What could have changed? How about the relay contacts? All these controls are done by variable capacitors. This ain't no red plate. That's blue's not on there. I don't know why it looks like it. Or at least I can't see it until I have the phone there. Now I have it triggered, so the blue one lights up too. The red on top means it's bad. But we can't throw tubes away these days. Well, I had that lighting up earlier, so what has changed? I burn out the filament? You know. Well, I'll do that again. So anyways, we got this thing running. I'm gonna pause this for a minute and flip this thing upside down for a moment. There's a lot going on inside this thing of power supplies. It's got the 12.6 for the filaments. That's a 12 volt filament on that SOB, and I can't identify it. 12.6, 12.6, 12.6, and 12.6. This is a number 57, I think it was. I don't have my reading glasses on. It's a GE number 57. So it's got to be a 12.6 volt filament or a 14 volt filament. So, okay, these capacitors were all changed. There's a lot of heat coming out of this thing right now. There's no voltage though. I checked this. When this thing's not transmitting, there's no voltage on that tip cap. Plate cap. So I want to see if these things are available. These are old-fashioned IC chips, I guess. Before these, I guess. I don't know. Apparently those are IC chips. I thought they were just like 2 transistors or 3 transistors. 369, they could have 3 transistors in there. I think there's 12 wires, I think. That son of a gun is still hot. Why is it so freaking hot? Still feels like a lot of heat in that sucker. Well, maybe I should unplug this. I'll hit transmit one more time. There, we got something. Why now? Come here. The hell's this beeping? It's actually an orange color. Doesn't look orange. And this will red plate. This blue that it's showing right now is not legit. That's filament. It's just not orange. That blue is legit. Same on that two back there. I don't know where the oscillation just come from. But the element is no good in here. No, it's dim. Oh well. I gotta shut this thing off. Okay. So, boy, that tube is hot. I have to make a better case for my testing light bulb. I think it's supposed to be all in a metal box and all shielded and all that stuff, so I couldn't find one of these, otherwise I could have did a better job. I have one around somewhere, the female section, so we got all this stuff happening. So what I had to do to get the filaments working, I had to, okay, these ones, top and second one down are ACs, which are these. I had to take this one next to the last one on the top right, and I had to take it down to this top, no, this middle, no, the top left and the center. One of them is to hook up to the filaments, and the other one is to hook up to the top of the full wave rectifier. Now the gray ones, okay, this is here where I wired them together. This is where I started from. So that has to wire. I don't know how they're wiring each other. It's just the way I did it. Soldered 2 wires on and then cut them to length where I needed them to go. Otherwise, I would have forgot what the hell I'm doing. So I needed one again for the bottom side of the filaments, or the other side, and then I needed one for the bottom side of the rectifier. And 2 of these over here. So these 2 here, this gray and this one here, these ones right here, I know our AC. Now this is all AC voltage here. These are AC that will run this solid state section. And that's why I couldn't find that transformer I wanted. That I use, a Radio Shack transformer I used to use for work with low voltage stuff. I can't put my hands on it. So I have to, my intentions are to drill a hole in here, or put a couple of those plastic loop things and loop it up here, then zigzag it so that it's not a danger. I mean, if you touch it, the only, I mean, there's some high voltage ones here, I believe, yes. These 3 on the right side are for the oscillator, for developing, if we're using on storage car batteries, to run the oscillator to get your high B plus. So are these top 2. No, these 2. Okay, when it was upside down, actually it's these, yeah, these 2. When I was doing it upside down. So when I did it, everything, this is upside down back view. So these 2 are these heavy wires that come in from the storage battery, goes to the switch or whatever, and comes back to here. Then I think it gets sent over to here. That's what I'm thinking. So when I was going to put 3 and 4 together, it would have shorted out the transformer. I was luckily seen another schematic, totally different thing, but I was able to look at the power supply, and they use the power. I think they use the same power transformer design. You know, the ones for going in vehicles. So I hooked this the way I have this here. Okay, this is way I have it hooked up. These are the frequencies that are in here, but some of them I don't think I could read very well. So I got my wires hooked up. I got a black wire going to here, or a black from the transformers going to here, and green from the transformers going up here. Same thing with, I chose the yellow to go at this and brown to go at this on the filament. So that's what's going on. So I picked 3 and 5, and those are the high voltage. So I picked 3 and 5 here, 3 and 5 to run it was, I think, 13.5 volts, I think. I originally was going to go at 4 and 3, I think. No, actually, I was going to put those together and run off the ends and get 11 something. But going from 3 and 5, so 3 and 5, 3 and 5 is the legit way to wire it up. So I had to put some more turns in there and put those together. So see, these filaments got me 3.73. These windings got me 20.6, and nothing worked, especially because all these filaments are. I'll flip this thing. So it's pretty cool system, I think. The only thing I don't like about this system compared to this system here, you can go to solid state right there, and you got it. Is that in focus? Then you got both, and I guess this is for transmitting weaker, so you can use a VFO or whatever. And I got to learn about that. That's this one. This one doesn't sound as good when I'm receiving. It's distorted all the time. So I was trying to adjust the biasing back here. These are screws for the cover. But I could maybe learn how to adjust. There's a lot of cans to adjust, so I could see myself, you know, making a mess out of that. So, okay, these 2 wires are speaker wires that somebody put on. So I'm going to flip this thing upside down for a moment. And so there's a lot of bending my brain to figure this out until I stumbled on to look at that one schematic and I seen that transformer. But I would have hopefully used like a whisker wire or something, putting those a way lighter gauge wire to put those transformer windings together, because they're really heavy windings. They're not thin stuff. So here's what I put in down here: 2,200 twice, 2 different spots. I think these 2 resistors are the ones that bleed down the high voltage. So, and this is not very good stuff. If you were to replace an IC chip on it, this stuff will all come off, so it wouldn't hurt to have some real nice pictures. I think this is the rectangle I see somewhere around here. They do have, I think this was a test point. I should curl a loop in it. So here's the AC you can hook up if you want to resemble that Heathkit one. Put AC in here at, say, 12.6, then it'll power up the receiver only. I'd like to put a switch on here. I don't know what this is about. Put a switch on here so I can have that for like AC, 12.6 volts AC, and then switch it the other, or 12.6 volts AC input here. Have a switch here, or this. I don't know what this is. I think somebody added that. It don't look like a legit thing. But I'll have to cover this up. So that's it on this one. So like I say, I will have to, I don't know what this is for. This might have been an add-in too. But I like to put a toggle switch so I can have an AC input. That ain't a lot of, just, you know, in the small milliamps. So if you want to run this thing very economically, you can. And this thing here, I guess, is that, what's it called? What's it called? That noise reductor. Well, maybe this don't have it. This thing's kind of funky. Whole thing's kind of funky. It works, but it's distorted. That's why I call it funky. So these I should have actually put 23 on it, but it don't matter. So if am I going to replace any of these other parts like that? I don't think so. Am I going to replace any of these? I don't think so. I don't think so. I don't think so. Because I can't transmit on it anyways. I'm not licensed. So I'll check at the severity of them. These are for the oscillator. These 3 capacitors. I'll probably do those. So if somebody wants to use this, they can, but they'll have to figure out how to do it. I'm going to go look at that. I have the download of it. I'm going to draw it out. It's going to be similar to, well, this is part of it. It'll be similar to this. This is what I started working on. I drew all these. Some of these are vertically up. I didn't want to get things all confusing on me, so I just did them all like that. So these are filaments. These are top and bottom, apparently, of the green and white. Oh, I don't want to confuse myself. What the hell are those? Green and white. Green and white. I bet you. Oh, shit. Okay, yeah, this is the way it goes inside, yeah. That's not wired that way, that's just the way it is. Factory. I was just getting confused. I'm using 3 and 5 for operation, I'm not using these. These are just factory the way it's wired. And these 3 end ones are for inverter or whatever it's called. And these are for inverter to run the fat red wire to the switch and back, send and return. Then they affiliate with those. Low voltage rectifier, that's what that's to, which is here. That's what these 2 wires go to here. I did draw in the capacitors. I think the fuse, they probably have a 3 amp fuse. I'd like to put it down to a 2 amp. I had to reconfigure my operation right off the bat. So anyways, I just use these 2, 3 and 5. I'll recheck everything, and then I'm going to have to draw it out this way and put down that this is for filaments and the top and bottom of the rectifier bridge. The black and the green. Black and the green off the unit. Green and the black. 3 and 5. 3 and 5. Enough of that nonsense. Here's everything I replaced. 5 microfarads would be 4.7. The one I had, the 50, probably a 47. The 50 again, 25. I have not a clue. Probably a 22. These 2500. These 2, them were what? I just shined on them. 2200, I think. I'll write them down. These 3 bottom ones are for the inverter. This diode I think is a Zener diode. I'll get to that. So by the other schematic, they had a C3053, which is, I figure, is IF, and this one 3020 is the audio output transistor. The tubes. The other tube I cannot identify. All I know is it's got 12.6 volt filaments. So, and this transformer, I left it running quite a while. It seems to run very cool. Doesn't get too hot. So these are the high voltage, which gets you your 425 volts in operation. So the ones I used was 3 and 5, whatever I think is the green. No, it was the white and black or whatever. Green and black. Green and black. This is real heavy wire. That's that solid one I had to move around so I could see the rectangle deal here. On this one, I'm going to mark the 2 ACs down here that run, they run the rectifier, so you can actually, if you just want to use the solid state section, you can at 12.6, 13 and a half, 12.6 volts. This thing here still needs to be cleaned up. There's the crystals. I couldn't read them very good. The only ones I knew that was for sure are these 2, and maybe that one. This one I haven't a clue. Oh, and checking, thinking I could use a frequency counter and stuff for these frequencies. Mine won't work. These are too high a frequencies, so I like to clean around here with Q-tips and lighter fluid. These capacitors have to replace. They'll be 4.7s. I have to do those. And there's another one of those that are probably like the IF. That one, these 2 have to be changed. There's just a couple more. I think there's another big one right here to replace. But obviously that's for transmitting, so it's not of interest to me, but if I was to peddle this off to somebody or give it away or whatever, somebody I could use. I'm keeping it in case we still have threat of worse than 9/11, I guess. But our new guy's doing a lot of good right now. A lot of good, especially going to be for California, and it's going to straighten things out, I think. He's going to straighten out the tablecloths and the doilies and stuff on the end tables. You got to talk in code. We have free speech, but it's watch and beware free speech at this time. So this is a 12.6 volt filament. We don't have a clue what it is. I do have a book. Let me pause out here. This is a two-handed job. Okay. Okay, I do have this, and I'm going to go through this and see if I can find it. But that's a lot of effort to look for something that's... I still won't be able to tell if it's this or not. So anything on it. I think one time it had a slight number. Like that. I probably rubbed it off with my fingers. But all I know is it's 12.6 volt filament. That's all I know. I can't find a schematic for this thing or no knowledge of what it could be, so no matter to me. I can't transmit anyways. I'm illegal to transmit unless if I took that course and pass it. It looks very complicated to me. Very complicated. It doesn't have one of those wires that stick up either. So when I get to the what is it, 10, 15, 20, 40, 60, can't remember if it has 80, I can take some of what I learned here and apply it there. Now I realize now about that negative control grid voltage when I was flapping that up and down on my oscilloscope on the last video for this unit. Was it this one? Yeah, I think it was this one. I got three of these sucking things. And I got the other one, has a transformer just like this, I think. Same exact baby. I'll shine on it in a moment. But I think if you don't want to use your a relay in that other one, you can build a little negative power supply in there to make the control grid voltages on the final and your 6CL6s in the other unit, and to go real negative to shut the B plus down. I wish I would have known that way back when I had my Sansui receiver when you switched it. I always switched my Sansui when it was shut off. This is it. Damn. There it is. This has the 2E26. Here's a, for getting your B plus, you got two 6AQ5s. Two 6AQ5s. 6EJ7 that they used in the old black and white TVs. You got a few others. Got a bunch of them 6, like in your normal radios, ham radios. 6BE6, 6BA6, 6BA6, 6T8, 6T8, not 6T8, 6AL5. Have the light bulb out. Yep, this is it. Signing off. This is what? January 27th, 2025. Orange Beginner's Corner.